Okay, so this is a set of notes on finding the standard deviation of a population. So before we got a formula for the standard deviation for a sample, and it basically measured the distance from the mean, squared it, and summed them, and then took that over n minus 1. So the idea here is in the sample, you know that you don't have the entire population, so you broaden the standard deviation a little bit by making the denominator smaller, hence the n minus 1, to leave some room for the fact that the variation of the population could be a little bit larger. So we kind of allow for a little bit of freedom there. When I do the standard deviation for the population, that s is now going to become a lowercase sigma. The numerator is identical except for now, instead of x bar, the mean of a sample, we have mu, which is the mean of the population, and instead of n minus 1, we have n, which is the size of the entire population. Now, this can be basically a little bit more firm because there's no wiggle room here. You have all the members of the population. So the standard deviation of the sample is always going to be bigger than the standard deviation if it were taken as a population, because we don't have to allow for the fact that we're missing any of the data from the set. So we're going to work through finding this with the same data set that we've been working with, this 287, 216, 260, 291, 210, 272, 260 data set. And what we'll do is we'll walk through how do you find the standard deviation of the population with using your TI-84 calculator. Okay, so the first thing that we're always going to do is add this data set in the calculator. So we go stat, edit, and then we're going to add this into list 1. So that's 287, 216, 260, 291, 210, 272, 260. Okay, so we have our data set in there. And now we're going to do exactly what we did before. We're going to go and run stat calc. Option number 1 is the one variable statistics. We're going to do that on list 1. We're going to leave the frequency list blank because we're working from a list of data and not from a frequency distribution or frequency table. And we hit calculate. Oop, there, come on. There we go. And you'll notice that the calculator gives you 2 different standard deviations. It gives you the SX, which is 32.1, which was the standard deviation if this data set was a sample. But we're assuming in this case that the standard deviation is for the entire population. So you'll see it's got this little sigma here. Sigma X is 29.7. So the standard deviation of the population, as we predicted, is slightly smaller than it would be if it was taken as a sample. So knowing what the data set is that I have, and whether it is sampled from a population or if it's the entire population, is critical to this, because it's going to make that slight adjustment because I have all the data. All right, so that's it. This is how you find the standard deviation of a population.